All right, so that's last video ever for your statistics career at Twinsburg. Four-step process for significance test and a mean difference. So again, we're looking at this mu diff, remember. So the null, of course, mu diff equals 0. The alternative hypothesis, so again, it could be one-sided, greater than or less than, or it could be two-sided, not equal to. Again, same conditions, normal and the random and the normal large sample conditions as with a confidence interval. So here's how you find your t-test statistic right here. Again, it's sample mean difference minus 0. Again, 0 is the null value. We assume that the mean difference is 0, so you don't really need that. So it's just the sample mean difference divided by, and then this is where it gets tricky. This is the big fraction bar. This is the small fraction bar. So make sure that is consistent on your calculator, right? Okay, and I'll show you how to do that here. Once you get your a standardized test statistic, you're going to use table B and the degrees of freedom, and you're going to find the interval for the p-value. And again, this is called a one sample t-test for a mean difference for mu diff. One sample t-test for mu diff. And again, it's one sample because it's one group of matched pairs. Okay, goodness gracious, what is this? All right, so it says, example 2, is filling tires with nitrogen helpful? Consumers Union designed an experiment to test whether nitrogen-filled tires would maintain pressure better than air-filled tires. They obtained 2 tires from each of several brands and then randomly assigned one tire in each pair to be filled with air and the other to be filled with nitrogen. All tires were inflated at the same pressure and placed outside for a year. At the end of the year, Consumers Union measured the pressure in each tire, the pressure loss in pounds per square inch, or PSI, during the year for the tires of each brand is shown in the table. So this is the actual data, right? So you take a tire brand, get 2 tires from each brand, give 1 air, 1 nitrogen, and we're going to subtract these numbers to get our mean difference. So they did it for us. The mean difference in pressure loss is X bar difference equals 1.252 PSI. So they did it all for us. Meaning that the air-filled tires lost 1.252 PSI more than the nitrogen-filled tires. Okay, so we did air minus nitrogen. Air minus nitrogen. The standard deviation of the differences is 1.202 PSI. Do the data give convincing evidence that alpha equals 0.05 significance level that air-filled tires lose more pressure on average than nitrogen-filled tires for brands like these? And again, it should say use the 4-step process. I'll do that now. Okay, so we're going to have to go back and forth a little bit because there are some important numbers on this page. So let's go forward. Okay, and let's talk about the state. All right, we're going to state that we want to perform a test. So we want to perform a test. And again, I kind of have to, I'm going to use my paper here that I have already filled out. Sorry about that, to talk about things. So we want to perform a test. At the alpha equals, and it said the alpha was 0.05. At the alpha equals 0.05 significance level of, and now your null hypothesis for a mean difference is always mu diff equals 0. Your alternative hypothesis, mu diff. And again, if you look at the problem, it says, does it give convincing evidence that the air-filled tires lose more pressure on average? So we're trying to see if this mu difference is greater than 0 because we are doing air minus nitrogen. Okay, and again, that's where mu diff equals the true mean difference and that difference is air filled minus nitrogen filled. In pressure loss. And that would be PSI for all tires of brands like these. All tires of brands like these. Okay. All right, so that's what we're going to state. Now we're going to do the plan. So first of all, this is a one sample t test for mu diff. And we have to do our random condition. So it says they obtained 2 tires from each of several brands, and they randomly assigned 1 tire in each pair to be filled with air and 1 to be filled with nitrogen. So randomly assigned 1 tire in each pair. And I'll just stop there. There we go. Okay. That's good enough for the random condition. And now we have to do the normal large sample. It doesn't say, or it does not say that the populations are normal. If we count the number of tires in the box, there are 31. Okay, so I wish it would have said. I don't think it does say it. So the n value is 31, and that's a good number, right? Because that's greater than or equal to 30. So by the central limit theorem, the sampling distribution will be approximately normal, and we can do this problem. Okay, so there's our state. And there is our plan. Okay, now I know it did give the dot plot, right? But go through your progressions: normal, sample size, and then dot plot. All right, so I'm going to erase this. Let's do the do now. So let's go back and look at the problem real fast. Let me see if I can do that. Yep. Okay, so again, we need to use x bar 1.252. We're going to use s diff 1.202, and then our n value, or n diff, is 31. And that'll be the numbers we use to find our t test statistic. So let's do that now. So to do our do part, we're going to do t equals, it was 1.252 was your mean, divided by 1.202 over the square root of 31. This will be our t test statistic. Again, when you do this, watch very carefully in the graphing calculator. So I'm going to put a fraction bar. I'll put the 1.252 on top. On the bottom, a fraction, 1.202 over the square root of 31. So see how I did that. Be very, very, very careful. All right. Again, I'll do it one more time. So fraction bar, with the sample mean difference on top, 1.252. 1.252. And then in the bottom, once you go to the bottom, press a fraction bar, and now you're good to go. Put the sample standard deviation on top of that fraction, and put the square root of your sample size in the bottom. And there's our t test statistic. The 3 does not change the 9, so your t value is 5.799. Again, rather high. Hope you understand. And again, remember that our alternative hypothesis was a greater than 0. So we're just looking for the right tail when we look at the table B. So this is not where you multiply the p-values by 2. You're going to do this as a one-sided test. So now we need our degrees of freedom. Your degrees of freedom are 31 minus 1, which is 30. And now we need our table B. We're going to go find where this 5.799 is located in the 30 row. So let's go do that now. So I have to find the 30 row, find 5.7, and you notice it's way off the chart, right? So I'm going to write down for table B 3.646. So for my table B, the only value I found was 3.646. Now, that's not my answer. That's me just trying to find where my t value is. I think some people are getting confused. So I have to go up. So 3.646, I go up. And 0.0005, that's not even it. It's even smaller than that. So we say that our p value is less than 0.0005. So your p-value is less than 0.0005. You could almost say it's equal to 0, right? It's a 0% chance of happening by chance. There's your p-value. All right. Okay. So I'm going to go ahead and conclude, and I will use just p. So our p-value of 0 is less than our significance level of 0.05. So we reject not NH sub 0. I was thinking of null and wrote an NH sub 0, the null. There is convincing evidence that, and now I just am restating the last sentence of the problem. It says that air-filled tires lose more pressure on average than nitrogen filled tires for brands like these. So again, the p-value of 0 is less than 0.05, so we reject the null. There is convincing evidence that air-filled tires lose more pressure on average than nitrogen-filled tires for brands like these. And that's a sentence straight from the problem. All right, man, and that's our last problem together ever in stats. So you got 2 problems in this assignment. One's a confidence interval, one's a significance test, and you are done. Congratulations, you made it. All right, ask me questions if you need help.